Oh, okay. Okay, now we have audio. Now we have audio. Good thing I looked at that. Yeah, I did some stuff manually outside of my normal flow. Well, mainly I updated the titles manually outside of my normal flow. There we go. And that resulted in me doing other things outside of my normal flow. So then everything was just done out of my normal flow. But I was the first thing I said was I apologize for that, the bit that popped up there in the beginning about the unrealized gain tax, because I didn't mean to have that up. That was because I did a manual title in one place. I didn't do it in the other place. But I was just saying that I think that it could have been a really good idea, but I don't think it's going to be implemented correctly, and big tech already exists, so it's not going to have any effect on big tech or owners of big tech, because obviously they already have their gains. So their gains, you can't retroactively, go back in the past and then apply it to the time that they were doing the gaining. So there was some nuance there. If you want to watch that video, it's on my Cool Age 86 channel. Okay. Okay, now we're going to get to dash keys finally. All right, is it? I thought it did exist on there. Oh no! It's type UN array, or no! It's not assignable! Let's see what this says. Or null or undefined, yeah. Think I need to do derive key, maybe? Let's go check. Because I believe that the thing with the next key is you can derive either type of key. So let's go look at derive address. Derive child. Okay. Okay, so derive child. The problem is derive child can return either a public or a private key. You know what? I think I broke the rule there. Oh, okay, yeah, I see what I'm doing there. I've got this warning. I'm like, well, this is an async function, and there's an await right there. But it's just for the purposes of... Where'd the index buffer go? Yeah, okay. So we can't use it after this point. We'd not be able to use it. Probably should get rid of that. Okay, so what was I looking for? I was looking for... Do we have something else? We got 2xpriv. 2xpub. Do I have the type with the private key specified? I don't know if I actually have a type for it. Because what I want to do is just force the type and say, well, I know I'm deriving it as a private key. So just force the type on it. HD key. Yeah, private key. Let's see here. All right, so I'm going to need to load up this address. with testnet. All right, we'll run the demo again. Oh. Well, that's not good. Okay. So maybe we're gonna have to. I don't know what we're gonna have to do here. This does not make me happy. Do, 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 do. Let's go to issues here. All right, using the latest version. This just sucks. It just sucks. All right. Who are the devs responsible for this stuff? It's one of those times where so many times I just wish that we'd finished the project we were working on when we were working on it. Oh, because it always comes back to haunt us every time. I was at a point where I was able to build this. I mean, of course, it changes every week, so I don't know. I don't know. I wonder if there's something else that needs to be done. I just don't know. I just don't know. All right, let's see what this says. Okay, well, let me go figure out what this is, because this might be something where... well, first, before I even get there, let me finish out the rest of what we came here to do, because I know that I can broadcast the transaction on my own. I know I don't need anybody's help for that. So one thing that we need to do is we have to add extra payload, which that sounds like a terrible name for it. Serialized for SIG. Typed and documented separately for clarity. Yep. Okay. Oh, I see what I'm doing here. I see what I did there. A footer or a trailer. I just can't call it extra payload. That just sounds, it sounds too trivial. I mean, I could if I have to, but it just sounds too weird. You know what I'm saying? All right, cool. So we got that typed properly. Serialize for SIG. All right, there we go. And I don't think that I'm actually going to put the code for the asset lock inside of here. I think that the way that this is working is going to be just fine. What was this, parse? Oh, yeah. Ooh. Uh-oh. Uh-oh. All right, we have an unknown here. How do we do SIG hash type on extra payload? Lock time, offset. I probably going to have to do with the version. All right, change the next lock time. Trailer. Yes. Do it the simplest way. Okay. So 2 bytes. Should I just copy it? I should probably just copy it. Let's take it almost all the way back here. Was it 8, right? Is that the high order bit? Well, we'll find out soon enough. Here's what we're going to do in the meantime. Var tx utils is an object. Booyah. And we'll grab this one. And then we'll grab this one. And then we'll grab this one. Dash tx, oh no. Tx utils dot to uint 16 le. Just passing the number 1. What do we get? Okay. Okay. Just double checking. That's what we think it is. Cool, right? Okay, there we go. All right, and then we also got to add here. Now, there is one question I have, which is, should the trailer have the size bytes or no? And I'm kind of the opinion that we should handle the size bytes. But I'm not sure what to do about that signature byte. Well, we could probably try it both ways and figure it out. It's also possible it's not part of the signature, although I doubt that. No, it's got to be, because the bytes have got to be there for the payment. Yeah. Well, yeah. Plus, it's got important information in it, like the public key. I'm gonna guess that when we're parsing, I have thoughts. When we're parsing, we should assume that There could be extra bytes at the end. If it's more than a single byte, then it's not the SIG hash byte. And when we're signing, the entire thing should go, and then that seems obvious. That seems the obvious thing to do. So they probably did something different. Nobody ever does the thing that makes sense. What are you, stupid? Some kind of dummy? People aren't going to do the thing that makes sense? You tard? You eat paint chips? Ah, sorry. So I'm putting these in byte order. You know, that there's just sometimes there's a time for the time. And that time is now. And every day. Yeah, I'm gonna put those in byte order. I was putting them in alphabetical order, but it's wrong. Now I'm putting them in byte order because that is right. Not to be left out. UN 16, baby. Okay. And then the parser here, that sig hash type bit. And we gotta worry about that now. Let's see. Where are we at here? All right, trailer size hex. And this would actually be a varant. Oh, wait. I remember what we do here. This would be... Sorry, this would be... If tx.type greater than or equal to 8... That's how we do it. We check the type. So if the type is greater than 0, bogey on your left. I think that's about all I got. Please, old friend, don't take her. She's all I got. All I got. Not friend. Don't take her. She's all I got. I don't remember why this -8. It doesn't quite make sense, does it? Oh, right. Right. Okay, this does need a comment. Okay, so that's pretty much done then. Oh wait, and then we still need to figure out when we serialize. So we're going to serialize the version. We need to make sure that we're also serializing. Let's see. All right, so that's when we pass it. Where do we serialize that? All right. To do variant. Now. There we go. All right, I think that's it. I think that's how quickly we add version types and trailers to -tx. Now we run the tests and watch them all break. Are you ready? I'm ready. I'll watch all the tests break. Okay, let's see. npm run tests. All right. There we go. That's one of them. All right, let's add trailer in here too, huh? Boom. Oh, I know what went wrong here. I know what to do. I know what to do. Everybody hang tight. I know what to do. Nobody panic. Nobody panic. I've got it under control. Everybody, stop panicking. This is kind of null-ish. I'm going to put that as null. We'll see how that goes. We'll see how it goes. All right. Thumped all the things. Do I need to add any special tests for this? I'm pretty sure everywhere the version's copied, trailer is copied, so it should be all good. All right, so what I'm going to put here is simply let's Does it lock? All right, this is something I think Niles might like or be able to use. All right. All right. Oh. What about the legacy dot? No? Okay, yeah, that's not really important here. All right, yeah, I think this should be good. I'm going to go ahead and we'll just copy it over for now. Let's see. All right, we can get rid of that. It is useful to point out that a registration funding key is a source of entropy in the unique identifier of the identity it will fund, and this is obviously not the case for top-up funding keys. Okay. I don't know why we would need a top-up funding key. Don't know what that's saying. All right, I'm going to close this one out for now. Okay, we're not done with those yet. My guess is that this is too old and we need something newer. Oh. Let's see. What is this? Oh no. Oh no, that's terrible. They changed the default branch. What is wrong with these people? What is wrong with them? What are you new? Come on. What? Nope. All right, no comment then. Like they're in their own little microcosm. They don't they're not web developers. They're not doing web developing things. They're not like communicating like you would on a team. It's so weird. It's no. This is like it's like a private company. It is like how projects function inside a private company. It's not like how they function in open source. Oh, this looks really helpful. This is closed source code being published in the open. In terms of the what's the not like the way that the development goes on here. It's like it's isolated from the rest of the world. Okay, so let's not worry about that right now. Let's move along. Move along. Move along. All right, so what next can we do? Let's go ahead and no, this is -tx. All right. I will do this. I would like to release a V1.0 for this soon. All right. So we'll copy that over so that we can test it. And what we need to do is create our asset lock transaction. Seriously fast? Wait, is it in here? Stop. Stop. Okay, is it in this one? Okay, JS SDK. Source. SDK. Client. Platform. Methods. Identities. Internal. All right, so I'm pretty sure this is going to be a variant. No, this is going to be a variant. Okay, there's the size. That we don't need to worry about. mean, I'm assuming. I mean, the size is always going to be there. Could be wrong about that. But there is a way to autocorrect that in the future if we have to, if it turns out to be a mistake. But I don't think it's going to be a mistake because pretty much everything begins with a length, and I think that that's the way it's going to stay. Okay, and so then it's O1 is how many? And then it's the length of the thing, right? Or wait, was it... One, two, three, four, five, six, seven, eight. So if we take these bytes, we reverse them. So we're going to take these bytes, we're going to reverse them. So I'm going to put this in front. I'm going to put this in front. And then I'm going to put this in front. Okay, so if we do that... Oh. I think maybe the bytes were already reversed. Let's try that again. Nope. Okay, and that 19 describes the size. And so that describes the size. So what are we left with here? Okay, 1, 2, 3, 4, 5, 6, 7, 8. One, two, three, four. What? 2, 3, 4, 5, 6, 7, 8. Okay. I think bytes look like this. Could be wrong. So what if let's just kind of see. This should tell us. We do that? No. No bueno. Alright, but what if we do this? Okay, boom. Got it. Alright, so this is the way that they're segmented. What I'm not clear about is why we have 0101. Version 1. Ah, that's the version. Okay, right. Size, the size, version, size, amount. Blah, 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 blah. What was that called again? Okay. Let's see. Okay, so we'll actually just do the 2 variant thing, I think. And then let's see. All right. I don't know if that's right. I have to double check on that. Oh, and then there's the amount, right? Okay. So the amount... So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Not sure if that's some sort of hash or something. Okay. I guess I'm gonna have to call that extra payload. Can't call it trailer. I'm going back on it. They gave it a weird name, but we're gonna keep the weird name. Trying to stay as close to the RPC as we can. I know we're gonna have 88 AC in other places, aren't we? So change address. It looks like the value Stop return. X. Null data. That sucks. Why burn Dash? Why? Why would you take money out of the economy on purpose? All right. Hmm. Okay. Oh no, this is not. Yeah, nothing about this is really the same, is it? There's only, I mean, this really doesn't make sense. If there's only ever going to be 26 million Dash, and it cost 0.01 Dash to create a username, then there could then you'd literally you'd run out of Dash before you could get half the people on the planet to use it. How is that money for the people? I guess yeah, that's easy enough to fix. Somebody just patch the software and then release the money again. But that just seems so strange. Maybe there already is something in the software for that. Hey Joe, win Evo. Oh man. Ugh. Ugh. Oh. Alright, we'll export this. Wait, did I just do that in the wrong place? I just did that in the wrong place. I just did it in the wrong place. Wrong place. Ditter. Whoops. Alright, so we got that one taken care of. Now we're going to type this up. Type it to me, baby. Uh-huh. And all the girlies say I'm pretty fly for a Dash guy. Alright, so what's this? Got a prop here. Has a mount. And what else? Oh, so one problem that we do have with this, though, which I think I can check the documentation to find out. Where was the documentation? Because there is a problem that we have, which is that I don't know which of these bytes are repeating as part of this versus something else. So let me see if I can find that real quick. And this, there might be a checksum in that, or I don't know. I don't know what it is. I think we'll find out shortly. Core reference. Oh. Okay. Special transactions. TX type. Cool. Oh, so apparently we didn't support ProReg TX before, but now we can. All right, so what does a credit output look like? Okay. All right, and these are the same. Credit output number 1. This is such good documentation right here. Why do they just call it varint? It's the correct thing. Why do they call it that? Okay. Okay, so it looks like there's a finite number of these special messages. 1, 2, 3, 4, 5, 6, 7, 8, 9. So maybe all 9 of these could be moved into -tx. I want to leave them out for now and let them grow until we discover how gnarly they really are and what their use cases are. But Okay, asset lock. Okay, so that's actually quite simple. So we don't have to play that game. I'm putting this in the wrong place again. I need to move that over here. Okay. Actually, why don't I just copy that back over again? That makes more sense. All right. All right, so we still have this question of to what degree are these the same? Ends in 2C. All right, so the question is, are these the same? And the answer is no. And the reason I'm guessing that is I think this is some sort of checksum. All right. So it's probably a simple enough checksum to do. We just need to know what it is. Is there any way of predicting that asset lock? Okay. Okay, dip 2. All right, let's go take a look at dip 2. Dip 2 might have the answers. Uh, Let me try to find in here. Okay. Okay, what was that from? Alright. Okay, so, but it might be in dip 11? Okay, there's a schema. Is there... Oh, okay, okay. All right. Why? Use the code formatter. Come on, people. What are we doing here? Okay, I'm not crazy. Maybe this is my fault. Is this my fault? Maybe this is my fault. Let's try again. Because, oh, I selected style is equal to plain. Okay. All right. All right. Okay. All right, so where is the asset lock defined? All right. Okay, got it. So, asset lock number of inputs is equal to number of credit outputs. Or number of burns? Number of burns is equal to number of credits? Yeah. Is that what it is? I have to double check on that. I just don't get it. I don't get it. Never mind. How, how can you be this Rust developer with all these, grand imaginings, and there must be some way to reclaim it, because you wouldn't burn, because the whole idea would be you want to be successful, have lots of transactions, right? But if you burn the money, then after the 23 million transactions, you're done. You're burning the money to lock an asset or something. I don't know. Because this is not just for creating the username. This is any type of asset lock, right? So to fund okay, protocol version type asset lock out point. ST fee. What's ST fee? Okay, so where does it define what this thing is? Okay, what's this one? All right, now we've got the signature. Wait a minute. Hold on. So, do we not include the extra payload in the original signature? Come on. Come on. So I'm so we're doing okay. It would not surprise me. It would not surprise me. Back to my comment reference earlier, people typically don't fix things, they just add something else on top. I think that they did not update the transaction to handle the signing of maybe they did not update the transaction to handle the signing of the asset lock, but rather they just signed the asset lock separately and then added on to the end. That also might make sense for them wanting other chains to not have to have proper tooling for Dash. If one of these Evo messages goes through, it'll fail validation on the first bytes. If if you did update the signing method, it would just fail. Whereas if you don't update the signing method, it's just junk bytes at the end. They might not even be read. You might just get garbage collected. Okay. I really wish it would just show what does the byte sequence look like. Show me the bytes. Okay, I'm gonna try this again. Identity creation requires 2 actions. Let me go over here. Of course not. Of course not. Okay, let me get back to that one I was looking before. Okay, special transactions here, yes. This is the best documentation that they have. However, it is very much missing information. Is very much incomplete. Was this Fez? All right, let's see if we can look at plain English and somehow figure out what it's supposed to mean. Why would you ever write this in English? How is anybody supposed to read that? It doesn't even define what the op asset lock is. Show me the bytes. Show me the money, honey. Whoa, really? Op asset lock is not... All right, so we might be stalled a little bit because we just don't have the information. It's just not here. What is it called? Is it an outpoint signature? Let's go back here and go back in again this way. Signing of transactions we get. Seaboard? What the heck is Seaboard? What? Is this the variant? Is that what this is for? I think this might be the thing that... Hmm. Transitions. Is this, like, what are the bytes? What are the bytes? Just tell me what the bytes are. Like, what is all this squishy whooshy English? Set the signature field to null. Serialize the state. Now, just what are the bytes? What is the state? How is it serialized? All right. Yeah, I think I'm gonna have to be out for the night. I think I'm blocked. The documentation's not there. Searching through the code, I can't find more information about asset locks. Maybe I can if I don't know. Okay, maybe. What if I do create asset lock? I don't know where the code is. I don't know if it's in the JavaScript or in the Rust. Top up. Let's just look in here. All right, wallet stuff. Identity address. Wait, how can I have an identity address when... What? Okay, one-time private key. So this is going to be a throwaway? Is that... So we're saying these are ephemeral? So we just generate a one-off? And my editor's locked up. All right, let's... I mean, obviously the editor shouldn't lock up, but there's something so complex about this code that the editor, as it's trying to traverse it, just fails. I don't... it's not a problem I typically have, right? Okay. Selection. Asset lock payload. Okay. Set type. Lock transaction. From... this is very confusing. Set extra payload. Okay, sign the lock transaction. Where did the lock transaction come from again? Lock transaction. Okay. Sign, that's normal. It's a normal signing there. So there's nothing unusual about that. But there must be some special code to handle those signatures. Because from this, it just looks like, oh, it's a normal transaction. It's just sign a normal transaction. I don't see anything about the payload being signed separately, right? Payload, payload, payload. Is it signed before or after the payload? It says it's signed after the payload's added. So that goes back to my original thought. But I based on all that stuff I was saying about CBOR, I don't know if I believe it. Okay, let's look for asset lock payload. Okay, it looks like it may not exist in the JavaScript. Transaction, payload, instant asset lock proof, validate lock transaction. Oh, that could be helpful. And the transition might be helpful. Special transaction, asset lock. Okay. We have that, and then I want to look at the validate. It's probably not going to have anything. It's probably going to be an empty file. Okay, use. It says use. Where is it defined? DPP dash core transaction. Special transaction, asset lock. I don't think it's defined in here. Where is it defined? Where is the code? What is it with these people? I'm like, it's every time. Every time. Every time. Where is the code? It's so frustrating. Every time I go to work in this, it's so many layers of just stupid abstraction. You can't find the code. It's over here. It's over there. It's metaprogramming. It's macros. It's like, where are the bytes? Where's the code? This is very, very frustrating. I've never worked in another code base where there's more code that isn't there. Where something is generating code. Now, that may just be due to my inexperience. But I've worked in some really bad code bases. But not being able to... I should be able to do a text search and find the code, because the code should exist. It should be in a file. The business logic should exist somewhere. You know, like there's all these files and they're just empty. There's nothing in here. It's like it's all boilerplate. None of this actually does anything. Like what the small amount that this does could have just been called from the function that's calling it, because there's nothing here to do. Because okay, it's going to have, you know, a sum here to unwrap it, to do this. Otherwise, it's got to return that, which has some type of error. Well, guess what? Wherever this is being called, you know what it's going to have to do? It's going to have the same conditional logic, because this might be unwrapping the sum here, but then it just rewraps it back here. And so then the thing is, instead of being a sum, it's going to be an error, a result type. And so it's going to have to unwrap the result type. So there's no real either push it further down and put the result type in this so that this asset lock payload type function returns a result type, right? Move it down there, or lift it up and put it so that where there's business logic, you're handling the sum at that point. Why are you gonna create a whole file to do one if statement, and then I'm no closer to figuring out where the code is? So I might just need to take a break because I'm getting frustrated too at this point. Because this is just asinine. And you would think, because it's being rewritten in Rust, right? Like, okay, cool. The Bitcoin developers, they were college kids. They had no idea what they were doing. You can forgive them for writing absolute garbage because they were noobs. They were just young guys goofing around in C++, starting from a homework assignment that they were given for like a chess game or something, right? Like, they got some boilerplate from a teacher. They were taught an archaic way to do things from, some weird book that had become popular for no good reason. All right. Is it great to work in? No. But is it understandable why somebody who has no coding experience, who's being taught complicated things from a professor, whose primary job is to make things look more complicated so that they can profess about them, does it make sense how that C++ code got to be utter garbage? Yes, it does. It's a garbage language. It was a garbage environment. It was inexperienced developers. We can see how that got there. You're going to rewrite the thing in Rust. You've got this golden opportunity to use a modern language. You get to use nice design patterns. It gets to be really ergonomic. You have this opportunity to just do something great. And I'm expecting the Rust code to be pretty decent readable code, just on the basis that from the Rust developers I've met, they're typically very engineering minded. They're not just coders. They really seem to be able to work through. I think they're heavy on the macros, which macros are bad because you can't find the code they produce because it's not there. But I don't think that that's this problem here. But it's just frustrating. It's just frustrating. Why are you gonna spend all this time to rewrite this stuff in a modern language and just copy the same patterns that you had before, where you can't make heads or tails of anything because you've got thousands of files that basically do nothing with little bits of, let sum, else, return. Okay, I took a sum type and I turned it into a result type. Okay. Where would this code be? It says DPT. Maybe we can find it in a cargo file. Packages. Maybe we can't see it because maybe we're looking at the wrong layer. Because, first of all, don't nest things this deep. But maybe from transaction, it's nested into asset lock, and transaction uses dashboard transaction. So maybe that's why we can't see it, because maybe I'm grepping on the wrong part of it. Okay, maybe let's just try just this, maybe. Okay, now we're getting further. Okay, so that's yielding some fruit. Maybe. Validate. No, it's not validate. It's wrapping a sum type in a result type. It's not validating. Validating would be you check the signature. That would be validating. Or you check that the bytes parse correctly. As in, you actually check the bytes, not just you check if you had checked the bytes. I need to go work on one of my own projects. I need to go work on one of my own projects. Like somebody needs to be held accountable for this. Where are the adults? I mean, like, honestly. Okay, I get it. You don't want to invest in the original code. You don't want to do any refactor. You don't want to do any cleanup. It's too fragile. It's sacred from the Bitcore developers. You know? At least that makes sense. Why are you going to rewrite it? Why are you going to rewrite it and do the same things? Oh, is there a native BLS module? I think in this case, native might not mean native. Where's native BLS? I'm just curious, because this is one of the mysteries of the universe. Let's see if it's actually native. A lot of times, this is one of the weird things. This is just something that happens. People refer to non-native code as native, which is really weird. But the meaning of the word native has kind of become lost, and I think a lot of people don't know it. But native would mean the natural, native, nature, nascent, of birth, of origin. It would be the natural implementation. So you generally in Rust you wouldn't call something native because it would just be written in Rust. And as we can see here, boom, again, an empty file. So I mean, obviously it's not literally empty. There is something in it. It's just the stuff that's in there is not the stuff that does the work. So where is the stuff that does the work? That's the question, right? It's here. There's no work being done here. This looks like a trait, so interface, basically. So there's no work here, which is, it's particularly odd that it's called native BLS. Because there's no implementation. It's literally an interface. There's no business logic. There's no code. All right. So we're not looking in the tests. I think we already looked. Yeah, we already looked in there. That one's just valid instant lock. Where is the code? Okay. There must be another repository. It says DPP, which I assumed was this repository. What is this? What does this thing call itself? What does this thing call itself? Resolver, members. It says it's a workspace. Okay. So it says about itself that it's a workspace. That means that, if I understand correctly, and I could be wrong, but being marked as a workspace may mean, well, no, because it's saying these are the members of the workspace, right? Does this mean that all of this stuff is expected to be in this repository? Where would the DPP be coming from? Because it doesn't have a name here. Okay, let's see. Let's see, what have we got? It's got a Clippy, it's got a cargo. Maybe you have to make something. Show me the bytes. Just show me the bytes. Tell me what order the bytes go in. Show me the bytes. Like this documentation over here. This is nigh unto perfection if only it weren't missing the critical part that's the most different. Right? So we get down here to asset lock payload, and it doesn't describe the script, which is the most unique thing about it. Because the pattern that we see here, look, version, number of things, and then is it amount right here? Amount is the first, no, that's TXID. Okay. Anyway, point being, this is the most unique part. This does not appear to be documented anywhere. We know that there's some different op. I don't know. Yeah, I think I'm lost. I mean, is it possible it's defined? I'm looking for it. It's coming from somewhere. Okay, do we see anything? Is there a dash core repository? Let me check in the repo. Let me check in the repo. And then I think I'm going to try to find my own project to work on or something. I don't know if I even can. I might just go to bed. This is just so... Where is this? Is this in a private repository? Is there a repository that's not public, that's not in this organization? So they're rewriting part of Dash Core. Why are they doing this? I mean, it makes perfect sense to rewrite Dash Core in Rust in terms of having a clean slate, having it more secure, having it faster. But why? It doesn't make sense. Why would you rewrite it? And oh, we found something. Okay, where is this? Okay, so it's in 3 other repositories. Where is Rust getting it from? Okay, all right. So I was Okay. I don't understand the nature of whatever they're doing on their development machines, because this was not specified. Let me just double check, because it might be specified somewhere, but I don't know how. I don't know what I'm looking for because I'm not a Rust developer. Okay, so these things each have individual cargo files, which kind of makes sense. Most people don't do multiple go.mod files, but in fact you should if you want to keep the dependencies lower, because you could have your big end-to-end test suite in its own package and then not have to bring in the universe in order to just compile your code. Looking at you, SQL migrator, or anyway, simple signer. That sounds amazing. I have my doubts. Okay. Okay, RSDPP. Okay, so the code isn't here. Couldn't find it because code's not here. Code's over here. What? Like they're doing the same weird crap. Okay, okay, maybe not, maybe not, maybe not, maybe not. Because it's a vec, it's going to be of this type. So, but why wouldn't you just have it be a TX out? Okay, I don't know Rust well enough. I don't know Rust well enough. This looks weird to me. I have seen this before, but it looks weird to me. So what's happening is you can take something like vec and then you can cast isn't the right word, but you can give it functions that it wouldn't normally have. So vec would normally not have a consensus decode, but you can get this tx out vec that then has a consensus decode. And then I guess U8's doing that as well. So, okay, I might be mistaken. There is a way. I do not approve of this. I think that this is a bad pattern. That Rust was wrong to do this. This is one of the reasons that I left Rust. Is this sort of thing. This wasn't specifically it. This I was still okay with at the time, but it was. They started to add more and more of this kind of business. So U8 is a built-in type. Consensus decode is obviously not a built-in type, or not part of Rust built-in U8. There's a way, I don't remember exactly where you do it, but you can basically you can bring in something in a way very much like the macro problem we ran into with the serializer and the whatchamadoodle, the dash gov problem we ran into the serializer. There is that there was a macro that was defining all this stuff. So there's a way that you can pull the thing in, and then by virtue of pulling it in, so this might be it right here. By virtue of pulling it in, you overwrite the types, the default types, to have new methods. This is bad because you cannot tell from looking at this. You cannot tell where it came from, and then you can do all sorts of magic, just like what's happening there, where something unexpected happens. So this is decode. So what we want to see is encode. Yeah, and so yeah, so they are applying the same pattern from the C++. Now this is a little bit easier to read. I'll give it that. But they're overriding, or not overriding, they're supplementing the U8 type to have a consensus encode. This may be generated by a macro. I hope it's not. But yeah. So if you want to go find where this comes from, it's kind of difficult to figure out where it comes from. Let's see if GitHub can figure out where it comes from. No, it doesn't look like it can. Yeah, so the basic code tools can't figure this out. It's all right, but decodable, impl, encodable. Yeah, so they probably are what they're doing. It might be impl, encodable for U8, for example, and then it just, I don't know. It's not a good idea. Oh! There's bytes. Oh no, they're just garbage bytes. All right, well, that's unfortunate. See, here they call it var_int rather than calling it compact size. But maybe what it is maybe compact size is the var_int size. So rather than calling var_int size, maybe they call it compact size. I don't know if maybe that's a distinction they make. Public domain. Okay. Hey, props. That is if you didn't know, you cannot just say this is in the public domain. That is not legally binding. Oh, what's up, Black Mirror? Sorry, I didn't see you there. So props on that for actually having a legitimate public domain dedication that is legally binding. You sometimes can just say this is in the public domain, but generally speaking, it certainly doesn't work in the software world where you have automated tools that are trying to figure out what the license is, and then there's legal issues with different countries. Some countries, copyright law, like the United States, author has copyright by default. And in some cases, they have to. Anyway, so script buff. So yeah, the problem with this, unfortunately, is that what we get is just they're junk. They're junk. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. You know, it's just junk. That's the problem. So this doesn't actually help us understand the bytes. So the tests themselves don't actually test the code. Well, they don't. They test this one little aspect. Okay, let's get out of here. Asset lock. Is that really it? Okay, so I wonder if there's a sign. Let's see if there's a sign. Special transactions. Do we have a special transaction sign? Do we have out point? Do we have special transaction out point? Okay, from... Do we see anything about asset in here? I think I will look for asset lock again. Okay, script. Instructions. No asset lock. Okay, what would be in here? Normally the mod files are empty. Let's see if this one's any better. This one already. Okay, it's implementing. Was this thing we already looked at? Yeah, see, it's doing the same. It's doing the same thing that it's doing in the C++ code. Why are you going to rewrite it in Rust and then do the same thing? And then, you know, you got the same stuff here. Yeah. Like, take a result and then just wrap it in another result. What? All right. Hey, you gotta be kidding me. Come on. The code's not here either. Okay, so somewhere defines a consensus encode function. It's doing the same kind of thing as doing the C++ code, where there's hidden behavior that's not exposed, that you can't see. So you have this mod file where there's the asset lock stuff, but instead of having the code that pertains to the asset lock defined in the place where the asset lock is defined, that code is being defined somewhere else. Wait, did I already look at this one? Asset lock, special transaction? I think I did. Let me look at this again, though, because there might... Did I miss something, or am I just seeing it different? Oh, no, it's just same thing. Yeah. So I don't see how the signing is happening here. Okay, there was a couple other places where this is defined. But the thing is, it's going to be the same everywhere. It's the same everywhere. Everywhere they write this code, they write it the same way. They use the same type of like macro metaprogramming systems. They never put the code with the thing. You can't ever look up the name of the thing and figure out where the thing is. All right, the documentation doesn't say it. The code doesn't say it. Okay. CBLS signature? No, that's not what we want. We don't want that one. Okay, this is an asset transaction unlock. I really want to figure out where the signature is. I don't know. This is just really, really depressing. So here the types are. Where's the code? Okay, looks like it might follow. Signature. Transaction signature. Okay, fingers crossed we see something about asset lock in here. It's all a bunch of check code. Okay, there's some business logic. Or at least a data format, rather. It just doesn't really say anything. Not there. Well, we go to payloads. Okay, so what I want, I guess, maybe the payloads, this is where I'm confused. The document that I read, and maybe I need to read it again. It was very confusing. It is very difficult to read something that's in plain English when it's supposed to be describing something like byte signatures. That's it's the worst possible option. Okay. Let me make sure. Properties. We're talking about state transition, identity, create, transition. So we're talking about a transition. That's what we're talking about. Platform credits. So maybe the stuff that's going to the memo isn't being burned. Maybe it's as things happen on platform, maybe it gets reintroduced into the system somehow. I mean, that probably isn't the way it's done. They probably don't I don't know. I don't know. Well, actually, there was more than one thing there. I don't think it was just the burn. I think there was actually something else. So this is fees lock, asset lock output amount, fees for identity create transition. So not transaction, transition. And that transition is a payload. So what are the properties? Protocol. Wait, that's different. Hold on. This looks like it's describing a transaction, not a payload. Because it says protocol version, then type, then asset lockout point, then public keys. So that's just normal. But then this says signature. So now this doesn't make sense to me. Oh, this is not the blockchain message. Okay, so I may have been barking up the wrong tree here. Asset lock transaction. Okay. Transaction. This transaction. Okay, what do you mean this transaction? This transaction what? State transitions. Special transaction. And succeeding dip. Okay, so maybe there's nothing there. Maybe it's empty. So this was talking about a transition, not talking about a transaction. Transition. So the fees for a transition are in the lock transaction. A transaction. So now I'm understanding. Before when I was reading, I was getting these words mixed up. Because they look similar. They're off by what, a letter? Transition, transaction. Yeah. So I think I was not reading carefully enough. Wasn't using my third grade reading skills. Okay, so this is not going to help me. Okay. All right. Let's back up a step. I think I got into a red herring that led me to some assumptions. The assumptions may have been completely wrong. So let's go back and look at just, well, for one, let me go back and just look at the script. Script pub key, extra payload. It's an asset lock script, right? So we are correct. There is no documentation for an asset lock. There's a dip 30. Oh, 32 more matches. Asset lock fingerprinting. All right. Why does it show me raw? I don't want to see raw. Show me master. Can I get out of raw mode? Is there a button I can click to get out of raw mode? Oh, there we go. What's all this stuff about nonsense? What is this thing called? Replay attack prevention. So, okay. Ah. Yeah. All right. So where? Where does the data go? All right. So okay. So the assumption that I want to challenge is that this is not just simply a normal everyday run-of-the-mill pub key hash script. I think that I need to go look back at my own code because I don't actually remember how the script is created. It might just be created. Okay, lock script. It may be created with a hash, and so I may not be looking for a signature, I might just be looking for a hash. So let's see how this is normally done. So script type A, script type B. I don't think that we're doing these types of scripts. I'm pretty sure payload is not just this type of script. There's something different about it. Because I don't believe that it doesn't begin with opdupe. Or does it? What was opdupe again? 76 A9. So let's go take a look. Let's go take a look at the RPC. I could have been overthinking it. 76 A9. We're good there. 9A2C, and then it ends in 88AC, but there's this stuff in the middle. Equal verify check sig. Okay, so hash 160. Is that... Okay, good. I might just be tricking myself here. Script pub key. Is this right here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Is that... I counted wrong somewhere there, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14. So 7 bytes. There's 7 bytes that are unaccounted for. Are they just a normal part of the script that I've forgotten about because there's too much stuff in my head and I can't hold it all in my brain? Op equal verify op check sig. No. Pub key hash. How long is a pub key hash? Let me go check documentation. I'm missing something simple. Yeah, I'm going to put my timer on for 10 more minutes. And then I'm just going to force myself to leave because I may just be in a mental state where I'm missing something that's simple. There might be something that I know that I'm just not thinking about. All right, I don't think it's in here. Wait, maybe it is. Where's my big glossary at? No, but this makes sense because it goes up to 19. So this is normally 14. 76A9, 14. Is it possible that they're just using a different type of... Let's see. Like okay, 19. Oh, please don't tell me that the 7 bytes that are off. 1, 2, 3. No, that's right. Okay, let's just do some basic counting here. Something's wrong. Something is wrong. Dot length 40. Okay. Is it that this value is being truncated? It could be the value is being truncated and nothing's actually wrong. $30. This is not 20, right? What am I doing wrong? What am I missing? It's too short. Is this a real transaction? Is this actually valid, this transaction here? That's another thing I didn't think about. Maybe this is not a valid transaction. No, I don't think that's it. 9A2C. Where do I have 9A2C in my code? Okay, I'm getting a sense that this value right here may simply be truncated. It might be the display value. Let's see, how many digits are here? Okay, that's the full number of digits. Let me look at a standard transaction. All right. Standard length is 50. So let's take this all the way to the end. Which I was missing a few. I think I didn't copy these ones. 50. Okay. Okay. I was getting confused by nothing. I was getting confused by this debug output just simply being wrong. It's truncating the bytes for whatever reason. It's truncating the bytes. It's just that's it. That's it. I was reading too much into it. I thought this was giving me valid information. It's not giving me valid information. There is no signature. I was reading up on the thing about transitions. Transitions have a signature. I got confused. I started going down a wrong road. That's what happened here. This is a normal, everyday, run-of-the-mill. Well, no. I can't say that yet, because what I don't know is how the signing process happens for these. That is still a missing piece. But I have a suspicion that the signing process is exactly as I have done it. Okay, here we are. Boom, baby. There it is. Oh, chasing phantoms. I should have checked that sooner, maybe. Whatever. Okay, cool. So, good. See, when I create a one-line function, it's because I'm going to share that function somewhere else, and the one line has value. The one line here is doing work. It returns the thing with the bytes. Oh. Now, in some places I'm using parse, and some places I'm using serialize. Some places I'm using create. Well, parse and serialize kind of makes sense. They're parse and pack are more often reciprocal, but meh. Bless me. No, it's not always. It's not all. The context is not always that it's a lock script. This might deserve a better name. I'm not sure what that better name would be. Okay, what does this say? Get private. Oh, whoopsie. Whoopsie, whoopsie. All right. So where am I? Where am I at again now? Let me get that out of my way. It's blocking the chat. Oh, it's 64 bits. Amount is 64 bits. I'd also forgotten that. So there's no magic O's. I'd gotten confused because in some places it's 32 bits, but in other places it's 64 bits, and you know. I think that's what this is. Let me take a look one more time. So I probably need to expose the UN64 as well. Okay, okay, that's good. Oh, right. Okay. All right, so it's got it. All right, let's make sure this all makes sense. Yep. I don't know why I put that there. I wasn't even thinking. That's not where that belongs. That belongs right here. All right, so let's take U64 over here. We'll squish that. Hmm. Okay. All right, so now those are better. We'll go ahead and just copy that here. Okay, so now we've got 2unt64. I'm pretty sure that's right. It could be for something else. I could be mistaken about what that is. When we looked at the code, all I saw was the amount. Let's go take a look at what the integer size was in the code that we were looking at, because that's a good indicator. And I think we had some Rust code locally that did have that part in it. What was that? No. Wasn't locally. It was in the Rust dash core. Let's go find the Rust dash core. All right, here we are. So this was asset lock. Let's see what size. Version was a U8. Credit outputs is a vec of TX out. Okay, so that is a normal TX out. Is that correct? It's just Satoshi's. Let's go check that out, because I can probably clean this up then. Value U64. That's it. All right. Okay. All right. So let's clean that up over here. That's it. Okay, so over here then, we don't need the special documentation for credit output, because it's just dash tx dot tx output. It's a little more constrained than that, but that's what it is. Let's see. TX output. There we are. All right, so we could move this over. I don't know. I kind of want to keep it over here until it's a little bit more developed, and then move it back in. But yeah, this is essentially what we need. All right, so let's go ahead and head over to testnet and fill up my cup some Mazel Tov. Actually, you know what I want to do? Let me go to, what is it? Coin join. No, dash join. Where did I host the testnet version here? That's kind of strange. So I can just... Okay. I'm going to go into the application here. And... That's weird. Oh, wallet phrases. Got it. Yep. Because I want to actually have multiple wallets. Okay, cool. So, how about this? We use this wallet phrase instead. Because this one's already got Monenes on it. It's got Monenes dripping all over it. Okay. Okay. So address index, that's one. I think it's not too bad. Ayo. Spent addresses. YQE. Yeah, let's see what we can find. Okay, YQE. That's got some Monenes on it. The Monenes is thick. Man, I feel so dumb. I feel so dumb. I thought the debugger output was correct output. Forgive me for thinking that Dash Core would output the correct bytes. Forgive me. Forgive me. Obviously, we know that's not the case. Oh. I have learned nothing. I've learned nothing. All right, so all right. All right. Okay, so what is special about this then? Why are we doing a TX out? So is this a key that we're going to use? This is like a fund script. So we're funding this thing and we're letting it know, hey, this is funded for platform or... Really? That seems ridiculous. What? You're going to burn 10 dash? Just, you're going to burn it? What? There must be some other thing that's allowing this to enter back into the system, because there's no way you're going to burn all that money. But that doesn't matter. Okay. Yeah, so my guess is that when it gets signed, the SIG hash byte goes at the end of the null version of this. So it creates a null version. Yeah, I'm gonna guess that's what it is. I hope that's what it is. But if it's not that, it's the byte's either gonna come before or after. That's what I'm thinking. Either the SIG hash byte is gonna come here, or the SIG hash byte is gonna go right here. So that shouldn't be too hard. Again, this is one of those things where we need test fixtures that contain a wallet phrase and that you can use the keys from the wallet phrase to verify the test fixtures. Again, I'm very upset when I look at, for example, the test Rust code and it's just zeroed out, or 0, 1, 2, 3, 4 for the script, because it's obviously not a real script. It's not helpful. It's not helpful. So we need, and having the real script is very helpful. But what is most helpful is having the real script paired with the key that we use to generate that script so we can generate it again without any problems. What's up, everybody? Okay, so now we're back to this. I'm pretty confident that we can at least create that transaction now, the asset lock transaction. So I'm back to a high degree of confidence we can create that. But since the code, I don't think the code is there. I don't think that this is published with that code. So we need somebody to publish the current version. So I'm just going to create a message over here. Oh, we got some more information. Hold on. No. Oh, okay. Yeah, whatever. Yeah, it's not even worth it. He'll solid if he sees it. And because they were saying the same thing, and he'll get that, like, okay, this information is missing from there. Okay. Um. Okay, I'm gonna go over here. Where did I just have that, Mabob? What's in my paste buffer? Oh, this is the other thing. Okay. Let me just open that up so I've got it. All right, so back over at dash TX. Do we have dash TX open? All right, there we go. Let's open this back up. I'll just copy this. Special transactions. Where'd that thing go? Return the dash back. They're still working on that. You're talking about for undoing the burn? so that we're not just deleting money from the economy. All right, here we go. Oh, whoops. Whoopsie. Is that looks like a typo. Oh, no, that's because it has the plus minus on it, right? Oh, in trailer. Okay, so I gotta clean that up too. Okay, so let me go look over here. So what's up, TL? Who are you? What do you do? All right, so I made a boo-boo. A little tiny one. Easy to fix. So I believe that this is the way that it ought to go. I believe the extra payload's going to come first, then the SIG hash type byte for signing. But it's either one way or the other, so it's not a big deal. We can flippy. Whoops. Ah, yes. Okay. There it's correct. Okay, was there one other thing I needed to do? Oh, I was going to rename this. Okay, there we go. Boom. Whoops. Modern is a better word. Wait, was this the wrong one? Yeah, current was the wrong term there. Okay, so we're not gonna do that one anymore. I'm doing a lot less complicated stuff than what you're doing. I was wondering about what all the keys and identity do and how to use. Okay, let's go over that for a second. So let's go back. So first of all, if you watch the first few minutes of the last video, I think it's 15 minutes in is where we get started once we figure out that the current code doesn't work in the browser. Well, it will, but you have to have extra steps, and the code that is published does not work in the browser. Or it is not clear how to make it work in the browser. No, it doesn't work in the browser. Or maybe I don't know whether or not the code that's published works in the browser. It does not look like it works in the browser. There's no documentation for how to get it to work in the browser. It doesn't look like it'll work in the browser. Anyway, so we've got dash phrase, dash HD, dash keys. So this is how you generate your wallet. So this is the new Dash SDK. And so basically if you're not familiar with HD paths, they look like this. And so this is just, mostly documentation here. It kind of gets used, well, not kind of, this just gets used as a constant. That's what this gets used as. It gets used as a constant, as a prefix for your HD path for platform stuff. So this is a platform path, a platform wallet path, essentially. And it's useful because of the way that you use derivation libraries. Okay, so anyway, so you create your phrase, you got your phrase, we typically don't use salts. Hardware wallets use salts. We don't use salts typically. You can. A salt will create a unique wallet. It's just another thing to aid in creating the seed, but typically that's left empty. So the first key you're generating at the root level is your wallet key, and that's what has the wallet ID. And then depending, now that we have multiple standards for derivation paths, typically the one that's used on the phone just for receiving addresses, unfortunately, different thing. Anyway, so you got the wallet key, and then so this first bit here, this is all traditional stuff. This is just getting wallet addresses the normal way. So you store the index, whatever index you use last, whatever, when you create your wallet, meaning you are the person that's creating wallet library. You just increment account index for whichever account it is, and for address index for whatever address is free next. And you find that out by using the RPC. If you haven't been using the RPCs, you can check out trpc.digitalcash.dev. I'm going to link that here. So you can use the get address deltas RPC. So this will actually work. Whereas if you've been using Insight or whatever else, you'll find that they don't work. You need to use get address delta and get address mempool. And this is in another video that I did as Digital Cash Dev. I think I did that on my own channel, the Cool Age 86 channel. But that's a really good one to watch. I'm going to bring that up. I will get to your actual specific question here in just a second. But this one, I think this was a really good series to watch. This was... Here we go. Did we get the whole thing done in one stream? I don't think so. Let me see. I think there was more than one stream here. But anyway, I'll link to this. No, not, oh, sorry, it wasn't this one. It wasn't this one. No, it was the dash join one. Anyway, we'll skip that. We'll get back to your actual question. Hold on a sec. Where was I at? Where was I? Oh, I was looking at the code. We're looking at the code. We're going over the code. So this is just normal wallet stuff here. This is what is going to get used. Well, technically they say to use a one-time address, but I just don't believe in that, because if something goes wrong, if something crashes, then the money's just gone. So, or I guess maybe it's not, because you're paying it to another address. So maybe it's okay as long as the transaction goes through. It doesn't matter. I don't know. I have to look at it again. But anyway, this is your normal wallet stuff right here. So we create a normal wallet, and then we do normal wallet stuff, and I'm going to get out an address and a WIF. The address is what I'm going to use as part of the platform stuff. So then we have the platform stuff. Now we'll abstract this away in a library to some degree, but this is all the platform keys. So for each identity, just like with account for a normal wallet, identity, you're just going to increment it to whatever identity you want to use. If you've got 10 identities, however it is you store that, if you store it by name, because that's up to you. Are you using a database? Are you using browser index DB? Are you using the iPhone storage? Whatever storage it is that you're using, it's up to you to decide how you're going to display that to the user. We do it with usernames in our wallet that's still in development. But anyway, then you've got these keys that are master key, high auth key, critical key, and transfer key. And for some reason, the numbers don't quite go in the right sequence. I think I may have this backwards. I think it was actually critical key goes first. Or is it? I don't know. I have to double check on this. I have to double check on the order, because I remember that they don't go in the order that you would think that they would. Oh, it's high auth key. High auth key is lower priority than critical key. I don't know if this is a bug in the current software that they've published, but the numbers are swapped. But we're keeping it the way that they did it. I'll figure out whether or not it's important. It's probably not important. It's probably a typo. It's probably a typo that doesn't even matter. But we'll find that out when we get there. Anyway, so you loop through these, and then you use your identity key to derive the whatever type of key that it is. And then this doesn't work right now. Currently, this does not work. The published version of this is broken. So if we run this, it just segfaults. I suspect that the published version is out of sync with the version that they're running on their computers. So they might have it checked out in a feature branch, or I don't know what, because they're using it. Or it may be that it was recently broken. I don't know it, but identity public key, I think it's just a wrapper object. I don't think that it's actually anything important. There's a lot of ceremony. Like they just love ceremony. Wrap things in the wrapper because I heard you like wrappers in your wrapper, so I wrapped up your wrapper in a wrapper, bro dog. I think that's all this is. I think that this could be represented as simply this is, but they got to wrap the wrappers in a wrapper for wrap it with the wrapper. Anyway, and then you have the bunch of keys, and that's as far as I've gotten. So I've not gotten very far on the platform stuff because I was just chasing my tail trying to figure out how to implement the asset lock TX, but I just maybe figured that out. There's still some stuff that I don't quite understand. I need to go back and read up on another piece of documentation, or maybe it actually is here. It's hard to tell because, I give it to them. It's in flux, but the documentation is all over the place. So this special type of transaction, blah, blah, blah. The hash of the public key used to claim credits on Dash platform. So I'm not sure. I'll go back and look at the other example code that they have to try to figure that out. I'm not sure what key that's supposed to be. If it's a key from the normal wallet or if it's an identity key, I'm not sure. But you're sending money to yourself through this extra payload thing. And I'm not sure, do these numbers match? Because you're going to burn a certain amount. So this is scary, right? This is a burn. Just burning 10 Dash. Bye-bye Dash. But it looks like what it's doing is, I think it's not burning it. I think it's going to recoup it. I think that there's going to be software added at some point that recoups this, because if you look at the amounts here, it's burning this amount, but then by virtue of burning it, I think that's just so it'll show up in things like Coinbase and Kraken correctly, because they don't implement platform payloads. And a lot of the software, the way that it's implemented, it'll just read to this byte. It'll just read to this byte and then it stops reading because it's like, oh, okay, it's done. And so it'll just throw a parse error when it starts to read again the next bytes, but it shouldn't break this from working. This should completely process with legacy software without breaking. It's going to have an unknown version, but everybody ignores the version anyway because it typically doesn't mean anything. But in this case, it's the type that refers to there being an extra payload at the end. And we got to figure out how it's signed. I think I know how it's signed. I'm pretty sure it's one of two ways. The thing that makes me wary is if they're trying to keep compatibility with this, then I don't know how that... I guess it doesn't matter if they validate the signatures because they're just taking messages that are on the chain, and if the message on the chain appears to have an invalid signature, I guess it doesn't really matter because it's on the chain, so therefore, that's more truthful than whatever their software is. So I'm just trying to think about how it's being engineered between the other systems that are consuming these messages. But anyway, no matter how it's done in some way, shape, or form. And then asset lock payload. So this has a public key, but I don't know what these mean yet. That's what I'm about to find out, is what these public keys mean, because I got to construct that public key. I'm going to take my key to sign. I'm going to take my input. I'm going to sign it to a burn. And then I'm going to sign it to the asset payload, and then I'm going to figure out how to use these keys. So anyway, I was looking at DIP 11 or 13, and I don't get keys for encryption, decryption, encryption, decryption. I don't get it. But what you're doing is great. Thanks. Definitely recoup. That is how EMNOs get paid partly. Well, we need to get, well, I've already said this. But I'm going to link to something in the Discord that unfortunately I don't think anybody read yet, and maybe nobody will. But money functions on economy. Like, you gotta have an economy for money to work. And that I can't, it looks like can I leak to my own message? Copy message. Here you go. Don't think what has to do something with a quorum? I don't know. I'm not worried about that one. But people are not focused on the right things. What needs to be focused on is master nodes providing web services to the normal web, the web that people use. And so that could be hosting websites, although I've got some caveats there. I think it should be things that are ephemeral. It should be the opposite of what most people are thinking. Most people think, oh, we're going to have something that's going to be stored for the rest of eternity. No, because it drives up the cost and doesn't scale. So until we have the problem figured out of how we basically, what we need to be able to do is take the blockchain, snapshot it, hash the snapshot, and then delete it forever. I mean, somebody will keep it, sure. But the MNOs and the miners and all that, what needs to happen is that all of that needs to get deleted. People should not put happy birthday in op returns thinking that it's going to be there for eternity, because eternity is a long time and there's only so many atoms that you can use to fit bits of information. Oh, and by the way, we reached that limit. So we can't make hard drives bigger. They might get twice as big. They're not getting 10 times bigger. I mean, there are ways we could build the boards bigger, but the thing is, at this point, in order to make more storage, we have to make the drives physically larger. We are at the limit of the atom, more or less. We're a few nanometers away. We could invent some new technology, but our rate of improvement on storage is not good. We are at the limit of physics. We are at the limits of the physical universe. So permanent storage is just a bad idea. It's not going to work. But things that are ephemeral are things that could work right now. So something that's data processing, like processing a video, processing an image, generating some AI content using an LLM or something like that. All of the master nodes do nothing with their CPUs. Their CPUs just sit there idle. So things that use CPU and things that use bandwidth and things that are ephemeral, things that use storage, unless it's something like upload thing where I'm going to send a gigabyte file, it's going to remain for 10 hours and it's going to disappear. I don't think that's a good idea. But if it is something like upload thing where you pay for a certain number of uploads and a certain number of downloads, like megabytes of upload and megabytes of download, that makes sense. But the master nodes need to run this, and that's the next proposal I'm working on, is the base system. So DCG, they're not really good at networking. That's not one of their core competencies. They're not really good at the web. That's not one of their core competencies. So they've got this system that, as you may know, nobody's been able to figure out how to get to work with Envoy and Zero SSL. And it's still, open question. When platform launches, there's no way to access any of it on the web, except for people that are doing this manual process, and it'll only work for a few days, and then you have to redo the manual process. So it's just not going to work. But what I'm going to do is I'm going to, if the proposal passes, I'm just going to build custom Go code, because web services are really, really standardized. So it sounds like, oh man, building a web service, like that's going to be really terrible. But the configuration, I've done this myself. There's another project. I spent so much time trying to figure out how to configure a layer 4 router that I was halfway through, and it was just one of those sunk cost things where, why am I doing this? And I knew starting out, I was like, well, I think it'll just be quicker. I know eventually I'll need to write a custom router, but I think it'll just be quicker if I use Caddy layer 4 But no, the documentation just isn't good. Like the use cases are, it's not like you custom build the code in Go. Go is the network, like all the infrastructure on the internet, all the Kubernetes stuff, all the stuff that you hear about with the big cloud, all of it's written in Go. All that, like most of the stuff's in the standard library, and the stuff that isn't is super mature. So you want to build a web router, and I say web because we're talking about the layer of TLS. We're not. Anyway, that can run on master nodes, and then people can get to the master nodes through that. First, it'll be master nodes, and then later it'll be Evo nodes, because the Dash Central group is going to have to figure out how to not figure out, like it's known. They're just going to have to make it so that the Envoy router that they're using isn't blocking the main web ports so that the web router can be used. But other than that, like, and that's a small issue. That's like somebody has to delete a line from a config file and they have to go change those auto installer scripts that they have in a few places. But the thing that I'm going to create is something that will work with software we create, so that a master node owner can basically check a box and say, I'm going to add some more CPU compute to my instance, or I'm going to add some more storage, I'm going to add whatever. You know, they figure out what they want to do, and they just click a button and enable an image resizing service, or a video resizing service, or an AI service, or whatever. And then, just like there's the MN list, there'll be a list where the master nodes talk to each other about which ones are broadcasting services. And it's a trustless system because you don't have to trust the results. Like, that's the thing. If it's ephemeral, you don't have to trust the results. So you can take maximum advantage of where the master node owners have their money just going to waste that they're spending every month on their master nodes by letting them actually rent that out in normal web fashion, but rent it out at a fraction of the cost. Now, there's currently, you know, this is the thing where you got to make the market. We know people want web services. We know they want them cheaper. What we don't know is well, I mean, I think with the marketing budget, I think it'll work just fine. It'll be kind of something interesting. It'll be the only Web3 product that actually works on the web, because no one else has created one yet. Anyway, so you agree 4 nanometer, 2 nanometer. Platform documentation is deletable. The ephemeral data sounds right. I don't think it's, well, it depends on what you're looking at. This is really good. This is really, really good. If all the documentation were this good, there'd be minor updates here and there. The problem is that most of this documentation doesn't exist. And you go look at that dip, and the dip is all, you know, look at this thing, look at that thing, go around in circles. It's just a bunch of academic blah, blah, blah. They're not saying anything. There's just lots of words. You know, it's like, they don't describe byte sequences. There's no tables of data. There's not, like, this is useless. It's not useless. It gives you a vague idea. It's like, this is kind of sort of how it might work. But this, okay, compare this to, what was I just looking at? Where's the other thing I was just looking at? But the thing I just had open, I don't know where I put it. Oh, it's right here. You know, compare this, completely incomprehensible, to this. It's like, boom, I know everything I need to know. This is the byte. That's what it means. This is where this goes. Now, that's not entirely true, because there are things. The signing stuff is not documented anywhere. The only way you can learn about signing is look at the code, or we do have signing documentation. We have documentation for how signing works, both in the README here down towards the bottom, because it's not something most people are going to need to worry about. So way past the API documentation, utility functions, UDOT functions, fixtures, anatomy of blockchain transaction. So I think it is right here, this link. This, we have how to calculate the various signatures. And some of this may not be completely up to date with the code, but the code is actually very readable, and there's an inspector that prints out the stuff like this. So things are better now. Anyway, connecting core to platform as a sidechain is not easy. The Envoy fix sounds great. Yeah, we can tell. But the thing is, I suspect that the Dash centralized group is not going to like the idea of masternodes being able to run stuff on the web. So it's something that the MNOs are going to have to vote for. And that's why I did this proposal, because I wanted to get a feeler out. Do people believe in the web? If we go back to digital cache dev, it's not, where is it? Okay, here we go. All right, so it's still a little bit lower than I'd like. I'd like it to be up in the 500 range. I hope that's where it gets. But the primary purpose of this, number one, buy in on the idea that we believe in digital cache on the web, and we want to lower the barrier to entry for developers, especially web devs. And then secondary is just applying payment towards this. So the MNOs are paying for the RPC services. And the RPC services, these are way better than Insight in so many ways as a developer. Like, you don't have to wait for Insight to update. Like, check this out, right? So here's Asset Lock TX. So if I was using Insight, I don't know if I'd see that. I don't think that Insight knows about platform. I could be wrong. But in any case, Insight lags so far behind. I mean, it has bugs for years, right? Most people just want to look at like the pretty pictures or something, I guess, on it. But if you want to get the real information, it's like, boom. Here's the RPCs. Pick what you need. In this case, this one is actually for raw transactions. So get raw transaction. I don't know why this bug is. I tried to look into that. I might need to have Jojo look at it. He might know why that's going on. But something is causing the focus to get lost as the typing is happening. I think it's because this is being updated, and I think it's stealing the focus during the time that the pop-up is supposed to happen. So I might just need to turn this from a text area into a div, a code block div, and that might fix that problem. But anyway, so you do this thing, and then boom, and there's the output. You want to change the arguments. Boom, there's the output. So anyway, yeah, all right. Thanks. I didn't do anything to make it look awesome. I just want it to work awesome, but I think that's what you mean. I just use a free template called MVP, and that's pretty much what I use for everything because it's designed for idiots, and I can't figure out CSS to save my life. That's not entirely true. I've figured out some very complex things in CSS, but I can't use it on the daily. I think voting is getting used to the big quarterly vote. Yeah, I don't know. I just put it up because I just wanted to do it. But now that I've got buy-in on that, I don't know what exactly to do next because, they say you want to get 3 yeses before you make your big ask, but I kind of just want to jump to my big ask. And my big ask is fund me to write and I don't know how to say it because I know a lot of the audience isn't technical, but I guess I'll figure it out. But fund me to write a web router at the TLS layer that will be compatible with forwarding to Envoy once they'll basically, I don't know if they'll want to do it. They basically just need to remove the 0 SSL and then not make the Envoy port configurable rather than hard coded. If they do those two things, then we can get the web proxy on there, and then I'll provide an interface, and it will look literally like this. Where was that thing we were just looking at? It's going to be this. It's going to be a form like this, but it's going to have the domains and stuff, it won't be this form, obviously. It's not going to be the RPC export, but it's going to be I'm just going to use this template, and I'm going to put up a thing that basically says manual certificates or automatic certificates. Domain, manual, or automatic. That's basically going to be the way of it. And then there's going to be something that shows what other master nodes are running the software, because each of these things is going to keep a list of, they're each going to query the MN, the master node list, and they're each going to query master nodes to see if they're running the software. And so then ones that are running the software, when somebody connects to one of them, and then we'll have a website like this where you can get the list of the ones that are running the software, but you can verify with the master nodes themselves that they're running the software. And it'll be from the verified IP list, and that has to happen. We might be able to do a DNS proxy in the browser so that users can do manual verification. I don't think that too many people are going to want to really be into that, but that's really simple to do. But the main thing is that the master nodes need to verify the domain names that are being presented by IP address. And, you basically, like at some level, you have to trust stuff, right? Like you have to trust the IP addresses. And that's a big ask, because Amazon owns those blocks. Amazon can just reassign them at any moment, So there's things that you just kind of have to accept. And we kind of accept that even though 90% of the master nodes are running on like 2 different Amazon regions, that I don't know. I don't really like that personally. That makes me squirm inside for all sorts of reasons. But, currently people just trust it. They're like, oh, Amazon's trustworthy. Amazon's not going to spoof the IP addresses. No, nobody in the government's at Amazon. Nobody in the government's got control of those IP addresses. They're safe, and IP addresses, unlike, domain names, it's not a free market. You don't get to shop around and say, yeah, I'm going to take this IP address and I'm going to bring it over to my house. I'm going to bring it over to my business. No, IP addresses, they are completely and utterly centralized. There is no room for any sort of decentralization in the political sphere of them. Obviously, the routing scheme is decentralized, but the ownership of the IP address, there's nothing you do about it. With a domain name, if somebody screws with your IP address, you can set another IP address. If somebody, if you don't like your domain host, you can just transfer the domain over. You can't transfer an IP address. So there's a lot more advantages to using the web because it's more resilient and it is by nature more decentralized. The IP system was an important foundational component, but we can't just hang on to all of its flaws and then try to fix them with Web 3, just entirely skipping Web 2. Anyway, I would enjoy your perspective of the DashPay data contract. Does it work like how you were doing contacts and incubator wallet? I don't really know what it does, but I can tell it doesn't, because the incubator wallet is just QR codes. So you're going to scan a QR code, and this is just boring technology. There's already spec for this stuff. So OpenIDC, OIDC, Errata 2. So you can go right here, and then look for, you can see, let's see, where's phone? Okay. So all of these fields are standard fields for web protocols. And you'll find them not just here. This is one of the places that I like to see them, but you can see some of these reference other RFCs. But these are very, very, very well standardized metadata, and it's common to put them in QR codes for stuff. So basically we're creating a contact card with some information like this, and then we're including some proprietary or additional non-standard claims, such as your XPub and the first available address on that XPub. So if somebody scans it, it'll work with an old wallet, but it'll also work with a new wallet. If it works with a new wallet, it'll take the XPub and the name and then provide that. And then we can do things like put in the profile picture URL or whatever else the person wants to put in. And then there's got to be some stuff, because people put dirty pictures or whatever, or swear words, so there's got to, I mean, if you're scanning in real life, you kind of already, there's always a level of trust that you already have with someone that you're paying or receiving payment from, right? Like when somebody comes from Facebook Marketplace to your house, there's some level of trust that you have, even if you think they're weird, because they're coming to your house, right? So there's some stuff like that where it's just part of nature. Like you trust that the person that you are sending money to is going to provide services. On some level, you just, and that's just human. That's normal. That's even good. But yeah, so it's just QR code. You scan the QR code, adds the wallet to your wallet, and then you can scan back, or the QR code can have a link back URL to get your information as well. And so it's mostly an offline system, but it would, it works in email, it works in text, it works with the camera, because the type of things you do when you do payments, I mean, think about, for example, Venmo. How often do you actually type someone's username in Venmo? I used to type in the phone numbers before they got rid of that. But once they got rid of the phone numbers, and that's the thing, right? If you know someone's phone number, you've already established something with them. At the point that you know their phone number, you have a valid, verifiable phone number, you already have something with them. So the username feature of Venmo was never useful. It was confusing at best because you just see a bunch of John Doe's, John Doe 13, John Doe 37. So his phone number or email address and his QR code. And the username feature was never really that useful. The username feature is only useful if I'm looking at past transactions and I want to see, or if I have somebody that's already a contact, right? So creating a new contact, the username feature is not, it just, think about all the web services that have ever existed. Twitter is the only successful use case, I think, because you tag people. And I guess Instagram follows that model too. But usernames are generally not a discovery mechanism. Usually, I mean, unless you want to say an email is a username, but again, we already have that. And that's already decentralized. You can be on Gmail, I can be on whatever else. Like the email system's already a decentralized system. That's another thing that could run on masternodes is email. Email is one of those things where there's a lot of gatekeeping around it because it's a very simple technology that's very valuable. And the people who are running email services do not want there to be a good option for email services. Now, trying to run it in a truly like a blockchain fashion, I don't know how that will work. But anyway, I think people will be for it, but explaining is always a hassle. Small steps are always nice, but if Envoy fails, you'll have a hot ticket. It's not that Envoy is going to fail. I mean, I don't think that Envoy is going to fail. It's that it's a non-starter. Like it's not going to get to the point of failing because it doesn't work. I mean, and this discussion was raised up just recently. How are we solving the zero SSL problem? Why aren't domains supported? And it was just kind of crickets. So, yeah, I don't think the MNOs are going to be wanting to do every 30 days or whatever it is. And then you can only do that so many times, and then you got to buy $100 a year subscription, or is it $100 a month? I don't remember. It's 10 times as much as a domain, so I think it's $100 a year. That's how I remember it. And I just don't think people are wanting to do that. They decided on a single service, a single point of failure. Let's Encrypt has lots of different implementations. There's, I think about 5 of them that are pretty popular. And then there's, some other ones here and there. Zero SSL has one implementation, just one. There's only one service provider. That service provider turns off the faucet, you're out. I think the email service is really interesting use case with all the public-private keys. I think this could all work together. Yeah, eventually. The email one is definitely something that you don't want to have an open relay, but you could do something like you could have software that just does not allow unencrypted messages. So you can send a message as long as it's encrypted. And you have some sort of, there are mechanisms in email and also gray listing. One of the best things that you could do for it, well, I don't know. I don't know. I don't know that master nodes are really a good use case for email in of themselves, but I think there's some things that are tangential to it that work out. Anyway, let me go ahead and try to create this transaction because we're really, really close on this. And then I think I'm going to go to bed. Okay, so I'm going to comment out this line right here for now. Or maybe I'll just put this whole thing in a function. Let's see, I called this one get all the keys, and this was some of the original code. So it's just doing a lot of ceremony here. You know, create this identity, create that identity, like once DPP is working, then I think we'll be able to I'll be able to follow some more of this stuff. I think we'll be able to get to the point of creating identity, but it's, you know, my confidence has gone up and down. At first I said, no way, I'm not doing this. There's no way that there's going to be enough budget to make this happen. Now I'm kind of back there. I'm kind of like, well, in for dinar, I'm probably going to have to end up doing more work than I'm going to be able to get paid for. Because this is still half-baked. This is not, they do not have a deliverable. But they may, you know, they could tomorrow, because if I'm assuming that the code that they're running themselves works, and we have seen, I think that Niles did a demo. Jojo at some point did a demo. I don't know if he ever actually got it working. I think Ryan said that Niles did it or somebody did it. I know that Mikhail was working on something, but I don't know if he actually got to this point. He knew a lot about it though. He's definitely probably the most knowledgeable person. He probably knows more about it than the centralized group does. Anyway, so yeah, I'm just gonna cut this code out here for a second. We're gonna do function create identity keys, but if you've seen the other work I've done, I will distill this down to the point that it won't be the fewest lines of code to copy and paste, but it'll be the easiest to implement. And the lightest weight. I showed that RPC thing to somebody who literally didn't believe me. He thought that I was faking it. Because it just, like, you click the button and like you can't blink. You just click the button, it's done. It worked. And he thought that I was faking it. And he made me open up the network. Well, he didn't make me do anything. But he had me open up the network tab, and he's like, I want you to do this. I want you to do that. This can't be real. I'm like, web development is made so complicated by people. It's not that complicated. It's really just not that complicated. It's just not as complicated as it seems to be. It seems to be much more complicated than it actually is. The web development people are doing is every bit as complicated. But it's because they're making it complicated. It's not, it doesn't need to be that way. But that's the entire internet. That's not Dash. That's billions of dollars of investment gone into telling people to skip learning basic things like how to copy a file into a folder and just use AWS. So, all right. So here, this is actually really, really, really easy. So we'll just set version needs to be 3, type needs to be, 8? I think it's 8. Yeah, 8. And then this we probably should put a constant on. This would be what? Type asset lock, something like that. We probably, if we wanted to, we say const version, platform equals 3. I'll probably update the library so that's the default version. It might be 2 right now. Okay, so you got the version, you got the type, you have the inputs, and then these are UTXOs. So I will, do I need, yeah, I'll unveil -tx here in a second. So what we'll do is we'll take our address. So I'm going to do -tx.utils.rpc, and then I'm going to give it the RPC auth URL of API null at trpc.digitalcache.dev. And you could put in, you know, localhost, blah, 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 blah. You do it however you feel best to do it. Or was it just RPC? I need to go check how I did that. Let me go. Or did I not publish that one yet? No, it's right there. TXUtils RPC. Oh, okay. I forgot to put the type on there. So TXRPC. I'm actually going to put that up at the top. So I need to go do this in the other one. Actually, hold on. Let me go do this over here. Whoops, not there, but here. So we need to define that. And then we need to define TXRPC. Okay, so... Oh, cheap viewers. Oh, sweet. Let me click. Oh, no, I clicked the block button instead. Thanks for the chat. Good night. All right, good night. Public-private keys on platform. I'll have to look into that. I'm just not that far yet. Oh. Okay, TXRPC to var int. All right, so we're actually going to take this away. And we're going to just type this as TXRPC. Of course, that doesn't exist yet, but that's okay. It will momentarily. Oh, I need to tell... Oh, dang it. I'm in the wrong one again. Dang it. I got confused. All right. Okay, there we go. Now that's typed out correctly. Okay, so let me copy that over here again. All right. Okay, so there we go. And so what we're going to look up here is I'm going to need to have a utility function over top of get address, or what is it? Get address UTXOs. Because that one, get address UTXOs doesn't actually work. If you want to get all the information, all of the correct information, you actually have to run get address deltas, get address mempool, and get address UTXOs. Well, I think you can do without actually running get address UTXOs, but it could be convenient sometimes. But that is, you know, it is what it is. All right, so okay, we have to create one output. Has to be this memo, which is just going to be empty string. We got that working again, and then it has to have some number of satoshis, and we're gonna have to wrap this like a create asset transaction or create asset lock TX. So this is not going to be 0, but I'm going to put 0 there for now. Then we need to have extra payload. And what we're going to do for this one is we're going to uncomment dash platform. And we're going to do dash platform dot tx dot pack. Is it pack? What did I call it? Pack asset lock. Pack asset lock. All right, and this is going to be satoshis. And then it's going to be what? Outputs. I'm just going to call it outputs. Credit outputs. Maybe we'll call it credit outputs. To double check on that. Pretty sure script is supposed to exist. TX output. All right, there we go. So really pub key hash is what we want, though. Okay, and all of this was bogus. I think that's right. 2 bytes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I have to double check on that real quick. Op equal verify. Pub key hash op equal verify. Okay. So no. That's not it. That 2 just happens to be a 2. That's not important. Okay. Cool. Okay. So we got version, we got credit outputs. What else we have? Is that all we got? So credit outputs are going to match and then I don't remember where the address is supposed to come from. So we're just going to send it back to the same address for the time being. All right. Change bytes. All right. All right. So what was it? No, I need to go dash keys. Let's go look at dash keys real quick. Add her to PKH. Yeah. Sure, let's do that one. So this is kind of the wrong way to go about it, but we're going to do it anyway. Oh, I'm going to go with... Let's see. Nope, nope, not a promise. Here we go. Boom! Okay, I've got the pub key hash. I've got the burn output. So we're going to have here our burn output. And I guess we just need to match these up. So yeah, the abstraction that needs to go around this is becoming pretty clear. Let me go take a look at that RPC Explorer again for, where was it? Is it this one? Or actually the one that was in the documentation was pretty good. Let me go look at the one that's in documentation. All right, so it's the total burn amount. Okay. Okay. Here we go. Here we go. All right, we're going to do it this way. So I'm going to say, how much do I want to send? How much do I even have? All right. So the burn output has to be the same as total credits. All right, UTXOs. Dang it. Okay, so that's it. What is this called again? Okay, cool. So this is coming together. And we should be able to do dash tx dot. Oh. Hmm. All right. There's a little bit of boilerplate. You know, I should be able to do this. I should be able to type this as dash tx dot whatever. Let me see what we got here. There should be a sign type. TX sign, yeah. And this should be TX get private key. And this should be TX2 public key. And then I think there was one more, wasn't there? Ah. I will bring this over. Oh, okay. All right, so get private key should be able to return null. That is allowable. TX get private key. I can return null. That's okay. That is acceptable. Okay, so we need to fill up our keys map with address. So this is going to be type object dot string and you know, this is one of those cases where I think that the we're just better off doing it like this. Let me go see. What was the other one? What did it need? All right. So account usage descriptor address blah 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 blah. Okay. Nothing useful there. Okay. Let's see. Key map, key details, blah 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 blah. Input address. What is this complaint about? Oh. Yeah, okay. Let's try this. Hmm. Yeah, okay, let's try this. Dang it, I'm gonna have to type it out. All right, there we go. All right, let's try this. Oh, keys mapped, huh? Get rid of all that sanity check crap. Info.private key, sweet. And there's one of these is missing. Get private key, get public key, sign to public key. Probably to public key. Or get public key, get public key. I could probably type this whole object. I probably could have just typed the object as key utils. Let me try that actually. I'm gonna try it. Let's see. Does that work? TX depths. There we go. Fix that right on up. And then okay, get private key. You want to go ahead and do that to get public key as well. Okay, we got sign, cut, and then what? 2 public key? All right, that's looking good. Dope. Yeah. So I think the way we get around that is we just throw a require on there. There we go. A little guard there. All right. Okay, so we gotta be able to have possibility that this can return null. It's possible that it may not get the key. All right, cool. What? Did I not save this? Save it. Okay. Did I not copy it? Oh no, to public key. No. Get public key. All right, what's this griping about? $382. So this is not hash and sign all. This is hash and sign input. So if we tell it specifically to sign an input and it can't sign it, that's no bueno. Alright, good. Well, that was a good find. Wait, what line is this on? Oh, create memo? I don't care about it. Alright, so key utils, and the best thing that we need, that we can do here, is just do tx key utils. Oh, you know what? I do actually need... Let me go grab this one. Get private key can be null. To public key cannot be null. Let's just make sure of that. Okay, good. Wait, why are we saying that to public key is possibly undefined? Okay, so... All right, let's run the linter one more time over here. All right, 383, huh? All right, there we go. So let's go ahead and copy this one. Alrighty. So there's dash tx right there. I guess we could just, we don't really have to instantiate it till here. Dash tx dot hash and sign all. And we're passing tx info. And this should give us back tx info. Or let's see, this is basically draft tx. Or tx draft, it should be called. And then this one is tx signed. So we take our draft and we sign it. Okay, so invalid address. All right, we may not have done this properly. TRPC, get address UTXOs. We might need addresses. Okay, let's double check the format that get address UTXOs is supposed to be in. Addresses. It's supposed to be an array of addresses. Oh, you know what? You know what? I think I know what's wrong here. So that's not supposed to be an array here at that layer. There we go. Let's try that out. All right, cool. Now we've got our inputs. So there's our total budget. I don't think we actually had enough. Promise pending, demo 53. Okay. All right. My fingers are starting to get carpal tunnel. I can't believe it, but I've been hitting the keyboard hard lately. Been hitting it hard. One, two, three, four. All right. There we go. And except for TX signed. Should have been awaited, of course. All right, there we are. Boom! So let's see what this actually looks like. Okay. So that's 1,000, 10,000, 100,000, whatever. All right, so this is our draft. This is important to label as such. And this is our signed. And then let me go ahead and grab this too. Oh, hey everybody, how's it going? I didn't realize so many people were watching in. Okay. Okay, so here we've got it from the top. We've got our address. We've got our WIF. Here's the UTXOs that are available to it. Here's our draft transaction. Let's make sure that this looks right. Oh, we got an undefined in there. That's not good. That's no bueno. All right, so how are we getting it undefined in our draft transaction? All right. Credit outputs. Oh, Satoshi's, we don't have the PKH in here. Hub key hash. There we go. All right, let's take a look again. From the top, UTXOs look good. TX draft. We got an input that's got some mo99s on it. We got an output that's just the input minus some mo99s. We could probably lower that a little bit. Then we've got the extra payload. Extra payload's looking mighty fine. We got O1 for the version, O1 for the number of things. We've got the amount. Then we've got the 19 indicating the start of the address. Where's the 14 at? Alright, something went wrong here. It's missing. There should be a 14 right there. I think we just didn't pack it right. I think I made a wrong assumption. So what we should see is a 19 and then some magic bytes, some magic bytes. So if we look here, it's going to 1976, blah, 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 blah. There we go. We're just missing a few magic bytes. All right. And again. So let's try this on an inspector. So let's try our trusty rusty decode raw transaction. Whoops. All right. Let's take a look at what this is supposed to look like. Hex string. Okay. There we go. Boop. And we'll go ahead and give it a try, see what we get. TX decode failed. Well, that's too bad. Let's see if we got any feedback over here. Was it here? Was it here? All right, so we're pretty close. We're pretty close. We might have some bytes off. Let's go ahead and just check what this extra payload looks like. Okay, this one doesn't have an extra payload on it. That's suspicious. Extra payload should have carried over. All right, so something went wrong in TX signed. So let's check that out. All right, so let's look at TX signed. Okay. Where's version? Create legacy TX, hash and sign all. What happens there? Hash and sign all. We should be able to call the serialize function as well. Let's see, sorted. Oh, do we not call sort? We didn't sort them. We need to sort them. Do we need to sort them? There's only one input, one output. We don't need to sort them. We should sort them. I mean, just as a matter of principle, we should be sorting keys, but there we go. All right, let's try this again. It looks a little longer this time. It doesn't quite look right, though. Extra payload is not the right size. So, what am I to make of that? Wait, oh, maybe it is. Maybe it is. Here it is, 24. That's going to be 36. There we go. Okay, that looks right. All right, let's try this one. Man, it's so nice to have these tools. I wish I had these ages ago. But at least I got them now. Hey-oh! Oh, wait. Soundboard's not up. Soundboard's not up. Get the soundboard up. Okay. That worked. It worked!
It's a Unix system. I know this. It's working! It's working! This was a triumph. I'm making a note here. Huge success.
All right. Cool beans. Now note, if you want to run this at home, you do need the -TX that has been updated to work with platform, of course. All right. So that is our what are we calling what do we call these things these days? We got so many different names for so many different things. All right. Where are we at next? Okay, so in theory we could broadcast that. I have a little bit of an idea to make this boilerplate feel a little nicer. I'm going to try it out. Right. Do I use that in the example over here? I hope I do. I do. Okay, good. Let's bring that right round, right round. Okay, so there we are. So there's key utils. So we're going to have let's see if we can do this. Yeah, you know, it might be really good to just have an example key utils file that uses a memory map. And then I like this. I like this. This feels good. All right, there we go. Use map equals key info update. How do I let's see. All right, let's do type def. Wow. I hope that woke everybody up. In case you were sleeping. Just give you a good old wake up. Put on a little bit of kick up. All right. Details and details partial. Boom. I don't really want it to be update as much as set. Key set. All right, cool. Let's see. What else? What all do we need? We need pub key hash. We need public key. We need private key. What do we generally need? What? Address? Private key, public key, pub key hash. I think that's generally what we need. We need pub key hash for TX outputs. We need, I think we need this. We need public key for, let's see, for TX input, for TX output, to sign. Generally convenient. Okay, how else is there anything else that we would use as a key identifier? We might include wallet ID. Yeah, I could wallet ID. Um, HD path. Oh, what am I doing? All right. Purpose, coin, account. Am I getting them right? Purpose, coin, account. Yeah. Let's see. Oh, was it dash HD? All right, there we go. I think these are your basic necessities, just so a bear can rest at ease. All right. And I can't remember what were we working on the other day. It was either CoinJoin or DashGov or something. There was some process that needed a little bit of extra love. I don't remember which one it was. All right. So we got that one going. I'm going to do something different. public key. Okay, so that's going to be good. Oh, whoops. One little typo there. Doesn't really matter, but just for the sake of it. Um, okay. Details. Wait a second for that, and then we'll push it. Let's see. So where are we at with where we need to go with this? We got the wallet all set up. We got a transaction that's parsing with the asset lock. And we are going to have to wait for identity public key. Either that's going to be just another day. We're going to have to dig around to figure out what the heck that does. Or, let's see. We have to create a transition. We have no idea what a transition is. Set public keys back after updating their signature. Sign transfer key. Sign critical auth key. Okay, so they're signed. Signed by private key by what? Create transition. Create transition. Create transition. So set signature none. Okay, or set null. Create transition. What do we do? What? How? Identity create transition. Asset lock proof. Identity. Identity is going to have all these keys. Okay, so where are we at? The asset lock proof is probably not hard. It might be the TX out. It might be that simple. Does anybody know what asset lock proof is? Is asset lock proof the same as TX out proof? I get a feeling it might not be. But it seems like it's highly related. All right, what else we got? Whatever ST means. And this one's super easy. We already have all that. So identity has all these keys. Yeah, public, private pairs. And I think that all these keys are the DPP version of the key. So whatever the DPP wrapper is, I think that's what this is. Then whatever the heck an ST is. And it passes in the identity, so it has all these things, but I don't know. Is it using the master key? What key is it using to do the signing? But the next thing we do is all we're doing is signing all the keys. Sign the master key, sign the high key, sign the critical key, sign transfer key. Okay. Then we set signature to whatever the signature is of all those keys. I don't know where ST transfer key came from. It's a public key. So we're going to sign the transfer key, or we're going to set the signature of the transfer key to the signature of all these things. And then we're going to unset the signature of the identity. And then we're going to set all the public keys. This just seems like so weird. Because didn't we just get the public keys from there in the first place? Didn't we just do that? Get public keys. Then we do a bunch of hoopla. And then we set the public keys? Is that because there's information in the public key that has signatures in it now? And then we're going to sign the transaction with the asset lock private key. And I don't know where that one's supposed to come from in terms of which HD wallet. But we do a heck of a lot of signing. This is going to be probably, I don't know, 5 times more work than what we did today. Maybe not, because once we figure out how the one signature goes, then we might be able to figure out how the next signature goes. Well, I guess if we... Here's the thing. If we can just sit on it and let them fix their own code, then we might be able to come back and then this section just works. So let's say, yeah. Okay. Yeah, so basically we have these two components. We're going to generate all the keys, and then we're going to cross-sign all the keys, or I don't know if we're cross-signing or what kind of signing we're doing. We're signing all the keys. That creates us a transition. The transition is supposed to be created by the DPP library. So if that works out, all right, let's make sure I got this part right. GPT comments. Come on, get out of here. It's master key, high auth key, critical auth key, transfer key. That's the way it goes. Okay, we don't even have to put those keys out there, do we? Because the identity contains all the keys. So I think we just get rid of that. I really don't know what's supposed to go into the asset lock tree. I know how to create it, but I don't know which. So the thing we got to figure out with this. So the to-do here, which HD paths to use for which keys. I know one layer of the abstraction here. Is simply to bundle this up so that the burn output matches that. All right. So the other question is, what is this asset lock private key? Is this the asset lock private key? Whoops. We don't know. All right. All right, so we got the transition is what this is going to be. I'm going to run this one more time, make sure that it's not broken, and then that's it for me. That's all I got today. Yeah. Oh, this is frustrating. Oh, this is frustrating. I mean, this works. That's great. Just this process as a whole. It sucks to not have documentation or examples or any of the things. Or spec or working code. Okay, there we go. Okay. And with that, I'm out, y'all. Where was I? I don't know where I am. I'm lost. Are you my mommy? Okay, this one's not hard. I'm going to call that one done. Because okay, I'll do it real quick. I'm not going to do it, but. Okay. I'm pretty sure that was it. Let me just double check on the format there. Signed hex. That's it. Yep. Cool beans. Okay, so here's where we're at with our proof. Well, yeah, we're going to have to scale this back to we have to scale it back to just we create the identity. We're not making it to DP and M, but MS and MS. All right, there we go. So questions are, what is an asset lock proof? It looks like it might be TX out proof. It's something related to instant send. And the way to get instant send is get address mempool. And that one's kind of hard because it actually has to be the mempool in order for that call to work. Okay. Okay. Let's go, Rila! Ooh, ooh. I'm out, y'all. I'm out. No, today's not Friday, is it? What the letter L is it doing Friday? I don't know what to do with that. But I gotta go. Bedtime. Adios.